Ladies and gentlemen, Masringer is back, and today I'm going to talk about a bit of what I have been doing in the last week, and so made some progress. First, I have designed this impeller, this blower, and I have made the prototype for this, and here you can see there is like a motor, and there is like a ring here that I will seal, just like with this, with Shikaflex, with a sealant, polyurethane based sealant, and this is the scroll. Here you can see in the middle in the impeller blade, which is connected to the motor shaft. So the motor propels the impeller in there, there are these blades in here, and basically it blows the air outside. This is like a different setup, a device that I will talk about now. So yeah, I have made the scroll from two parts, the bottom and the top part. I have 3D printed it. It took quite some time and quite a lot of material to make the whole thing, but I have made it, and I will probably need to make some caps for the screws or cut them down, but probably like make some caps for them so that they don't hurt anybody or they don't, whatever. So the main part is that there is this little chimney here that straightens out the flow so that it actually increases the total throughput that the little blower can produce, as well as on the bottom the ring that I have shown is also for that, because there would be otherwise big losses there. We will need to still seal it, but that will give us probably like 20% ish increase of flow. So you might ask, why do you need this? The answer is pretty simple. I will make a burner in the short future once I have all the extra parts and extra accessory gears like rollers and all that shit, so that I can make the burning chamber and all that consistently circular, or not conical but like tubular. So for that, this blower will provide the air, because you might ask, but will it not melt if it is from plastic? Yes, it will be. It would melt if it would connect to the burner, but probably the burner chamber, behind the burner chamber, it would connect either with this or some other metal parts that would act as a natural cooling fin, I guess, in between the two, so this would not melt. And if there is significant heat here, I will add a heat reflective foil or some bullshit around that so that it doesn't affect the motor or the house, basically. For this would be good enough. And this is, if you don't know, this is for reference. I don't know. Oh, I don't have it here. I have it in the manometer right now. So this is basically like 25 centimeters or so. This is about 20 centimeters across, 22. So this is pretty big. And this is like a adapter that I have printed for it. This is a 45 millimeter to a 57 millimeter, because the previous blower was that one. That has a, not this, but this outside has a 57 millimeter. So I have made the rim, this tube here, that basically is a device that is screwed to the exhaust, and there is an orifice plate, which is a contraction. So the inner 57 millimeter diameter contracts to a smaller 32 millimeter diameter. Probably no light is going in. Whatever, it looks pretty nice that the purple is translucent a bit. Yep. So as you can see, this is the inner wall, and it contracts down to 32 millimeters. And basically, if you measure the pressure across the two parts, so here there is, because the pressure from here, it comes here, and because it can't shoot straight out to the tube, it has some higher pressure in here than here. Here it is probably about atmospheric, but here it is a bit above atmospheric. and the pressure difference is going to be proportional to the velocity, which is also proportional to the amount of flow that the blower produces. So the higher the flow, the higher the speed, because as you throttle the, let's say you have a hose, and if you put the finger on it, then the smaller cross section that the water can, or in this case air can exit, will accelerate the water, and your water can be splashed further away, right? So you can blow the water further away. So that way, as the smaller or take down contract the surface area, the velocity goes higher. Where the velocity is higher, the pressure will drop, so it will drop and then go out. So there will be a natural pressure difference between the two for this reason, and the pressure difference is going to be proportional to the velocity difference. So very simple, from a velocity you can measure the or how do you say this, from the pressure difference that you can measure, because you hook these two tubes to a manometer or to a little pressure sensor that I will use. Just here I have it prepping. I have used a manometer, which I'm not going to show. It's like a U-tube that has two ports, and basically you connect the tube tops to it, and then the water on one side, which is the higher pressure, will go lower, and the lower pressure side, it will go up. And basically between the two water column differences in height, that will give you the pressure difference, which will be proportional to the velocity difference, which will be you can basically, between the velocity difference, you can go back to the amount of flow that you produce. It is basically a correlation, and there is like a coefficient with the hole size, but that is given for the radial diameter, or the, what the fuck am I talking about? So basically you have the small diameter, which is 32, the big diameter 57, which is about a 0.6-ish contraction. You can derive with, I don't know, I have made it with ChatGPT, I don't know what the exact CD, that is like the coefficient that you need to use, but it doesn't matter. I have been able to derive a function or something like that, but it is very simple. It is 2-36 times the delta H between the water line, and that is going to give me my throughput, my Q, which is the volumetric flow across this shit. And why the fuck do I make it so long and boring? Sorry for that, but this is very important, because if you want to make a burner, you will need to provide it enough volume of air to burn the fuel completely. And that can be only done when you know how much air your shit produces per given amount of voltage or duty cycle. And that duty cycle will be determined, or the duty cycle, what did I say? Sorry. So the amount of volume per duty cycle is very important, and with that we can fine-tune the burner later. So we need to measure the volumetric flow, because yeah, we just know that. If you don't do this, by the way, you have no fucking clue what you are doing. You just have a blower and you hope for the thing to work. And let me tell you one thing in life and in engineering: when you hope for something to work, it will never work, or very 1 out of 10 or something like that. So barely works. Hope is not an anchor point. Hope is nothing to be based on anything. So when we make anything in life, first for a prototype it is okay, but when you want something like a burner, which you need to control, not just blow something and do like this is childish level. When people make stuff, just side rant here, but people make stuff that barely works and they call it a video, and a lot of people watch it, and everybody, like, nobody learns jack shit, nobody gets better, nobody knows anything more, they just entertain themselves, and then that's it. They have just wasted their time, and the creator gets money for his bullshit entertainment rather than educating the people that came here to watch something interesting, which in fact is just a waste of time because he didn't even have a single fucking clue what he was doing. And if you don't want to be a part of that retard group, I'm sorry to say that, but those are just actually like brain dead people, to be honest. You need to measure out the things, just like in engineering. You need to fucking do things according to, so to speak, the plan or to the playbook. But that means that you need to know the parameters. You need to know the flow throughput of the system. You need to know the pressure of the system. You need to know the temperature of the system because it fucking matters. And when you want to separate your work from child play to fucking engineering level design, then you will need to fucking measure parameters, not just, yeah, I have designed this shit, so just watch the video, please, guys, like and subscribe, and that's it. Because, yeah, for sure, you can make something work for 1 second, or 10 seconds, or 1 minute, then it melts, or fucking blows up, or it doesn't even work because the flame just, I don't know, blows off and then it's dead, the spraying goes on and that's it. Or you can make something that you like. I can run this part with a adjusted how do you say this, fuel amount that the burner will inject and burn at one given fucking time. But if I want it to control automatically and reliably, not just, yeah, it works, guys, trust me, then you need to measure things and you need to fine-tune things, and then you need to fucking do PID control and all that blah blah blah. But that takes this shit, that takes electronics, knowing that what the throughput, the pressure, all that kind of stuff is, measuring those things out and doing boring shit fucking stuff rather than, yeah, guys, I have made this, oh my fucking god. Yeah, who the fuck cares? In engineering, work and utility, as just I guess in life, is the main thing. Maybe women can get away with looks, but this shit, and maybe even women, if they do not work, meaning that if they are not like behaving properly, then they will get no fucking shit. They might get the attention, but they will not be used and discarded. Just like with women, I guess. Retard women will get discarded. Sorry to say that, but true. Nobody wants like a brain dead woman. Or man, actually. With men it's easier because men are based or more on utility. Women as well, I guess. But that's a side question. So a bit of misogynistic vibes at the end for the little haters, if you will. Hate me for anything besides this, whatever. So this is the point when we tune out, because we have left the... one more thing. I have started to learn this shit, which is STM32, which is not this, which is not the ESP-based or Arduino-based bullshit, which is very fine for beginners and for hobbyists, but for if you want to something serious, nothing runs on basically SPM or ESP32, but STM32, which is a different fucking beast. It's like a not a controller, but actually a miniature fucking computer, which is very cool, which I'm just starting to learn now. But yeah, this was it for today. Quite long. I think see you the next time when I will hopefully be able to make the STM32 work with the pressure sensor and read the pressure data per PWM that I wanted to do. Because with the manometer it's very difficult, because there is like 400 pascals at max pressure range of delta H between them, which is like 40-ish millimeters, 39 at max, RPM around 90, because it starts to wiggle at about 90-ish. It starts to resonate because of the imbalance. So I want to run at 80-ish, 85%-ish. I don't want to go up to 90%, which is very, very unstable, around 9-ish volts or something like that. So yeah, this was it. Thanks for watching. If you liked it, don't make sure that you like and subscribe. Yeah, sure, bullshit, but I appreciate you if you do that. So thanks for watching. Again, do the hard work, especially when you don't feel like it. No, fuck me. So yeah, goodbye.